Okay, 3.6, factoring polynomials. We're going to talk about remainder theorem today. Okay, this is going to tie nicely into what we did in the last 2 days, which was factoring. Okay, so polynomial division can be a tedious process. The remainder theorem is a way we can determine the remainder, which we call Rx, quickly and help factor the polynomial. Okay, so the remainder theorem. When a polynomial f at x is divided by some factor, the remainder is equal to f at k. Okay, take a look at this, f at k. So usually we have f at x, of course. K is going to be the root. So this lesson is so easy. Okay, what that means, I'm going to show you guys an example 1. Determine the remainder of this polynomial here when this polynomial is divided by each of the following. So the root for x minus 1 would be x equals 1. Let's call this f at x. So all we'd have to do is take f at 1 and sub in 1. Okay, so 2 times 1 cubed plus 3 times 1 squared minus 17 times 1 minus 30. So whatever this equals is actually our remainder. So 2 times 1 cubed is 2. 3 times 1 squared is 3. Negative 17 times 1 is negative 17. And then we just bring down the negative 30. So when we put this into our calculators, we get negative 42. So therefore, remainder equals negative 42. Okay, that's it. So for x plus 2, we know that the root is x equals negative 2. We're going to do the same thing. F at negative 2 equals, and then we're going to sub in negative 2 to this equation. Okay, so we have 2 times negative 2 cubed plus 3 times negative 2 squared minus 17 times negative 2 minus 30. So 2 times negative 2 cubed is negative 8 plus 3 times negative 2 squared is 4. And then negative 17 times negative 2 is positive 34. And then bring down the negative 30. Okay, 2 times negative 8 is negative 16. 3 times 4 is 12. And then we can just put plus 4 there. And then put that into our calculators. I get 0. So therefore, the remainder is 0. That means we'll put hence x plus 2 is a factor. Okay, example 2. Determine the remainder when this function is divided by 2x minus 1. So just remember, 2x minus 1, when we solve for the root, we want to equate this to 0. Okay, bring over the negative 1, we get 1. And divide both sides by 2, we get x equals 1/2. So let's plug in f at 1/2 equals, okay, 2 times 1/2 squared plus 5 times 1/2 minus 4. Okay, 2 times 1/2 squared is 1/4. 5 times 1/2 is 5/2, and then minus 4. You can do 5/2, you can do 2.5 as well. It's up to you. Okay. 2 times 1/4, like it's 2/4, which is 1/2. So if you want to put like 1/2, or you can put 0.5 is fine. Okay, plus 2.5 minus 4. This is 3. 3 minus 4 is negative 1. Okay, therefore the remainder equals negative 1. Okay, example 3. Find the value of k if there's a remainder of 7. So this time it tells us a remainder of 7 but it tells us like this polynomial is divided by x minus 2. So the root here is x equals 2. Let's take this polynomial. Let's just call it f at x cubed minus 3x squared plus 4x plus k. I haven't been copying them out, but copy this one out. So when we sub in 2, so f at 2 equals 2 cubed minus 3, 2 squared plus 4, 2 plus k. We get 8. What's 2 squared? 2 squared is 4, so minus 12 plus 8 plus k. Let's keep going. 8 minus 12 plus 8. I put this in my calculator. I get 4 plus k. So we know f at 2 equals 4 plus k. So up until here, we've done that so far. Our issue is that we have this k value. Well, here's the thing. It tells us that we get a remainder of 7. So instead of actually writing f at 2, we can write 7 equals 4 plus k. Right? Because when we subbed in this 2 up here, or I'll change my color. When we subbed in this 2 here, we could have said, oh, well, when we sub in the 2, and we could have just subbed in the remainder from up here, like the remainder 7, and brought it down. Or you can sub it in at the end, doesn't matter. So we just move that over, 7 minus 4 equals k, and we get k equals 3. Okay, for the scope of this question, it just asks find the value of k, we're done. If it says to like rewrite this, we could say like f at x equals x cubed minus 3x squared plus 4x plus 3. And we also say, if you want to write a therefore statement, therefore, when this is divided by x minus 2, the remainder is 7.